There's a planet next door that can explain the origins of life in the universe. We know that it was once covered in oceans and may have supported life as we know it for billions of years. We are talking about Venus, Earth's twin. Despite its appeal and astronomers' tireless efforts to learn more about the mysterious planet, Venus is one of the most challenging places to visit in the solar system. Fortunately, after Venera 14, a Soviet Union spacecraft that landed on Venus in 1982, NASA is finally ready to take on the hellish voyage to our neighbor, and we can't help but feel excited. Stay with us as we explore why NASA is finally venturing toward Venus and what to expect once the lander arrives. In the search for life, both Venus and Earth would look equally promising from a distance. They are both around the same size and mass, so you'd expect the gravity on Venus to work the same way as on Earth. Venus lies just outside the habitable zone of our star, implying that the temperature there could also keep liquid water stable. However, the ground reality on Venus is quite the opposite of its perception. We know that because many space missions have tried to land their spacecraft on its surface, but only a handful have survived its hellish atmosphere to send any valuable data. The last NASA craft to visit Earth's twin was Magellan in 1994, but Venus wasn't looking forward to its descent, and the spacecraft burned up quickly after plunging into the planet's atmosphere. Why is Venus so unwelcoming? Venus is the hottest planet in the solar system, even though it is not the one closest to the Sun. The reason is its dense atmosphere that traps heat in a runaway version of the greenhouse effect that we see firsthand on Earth with global warming. As a result, temperatures on Venus can soar to 880 degrees Fahrenheit, which is more than hot enough to melt lead. The intense heat has made it impossible for any spacecraft to survive on the planet. The longest a probe lasted was a little over 2 hours. That was the Soviet Union's Venera 13 probe that landed in 1981. However, scorching temperature isn't the only culprit in spacecraft destruction. The atmosphere on Venus is equally guilty. Venus's atmosphere consists mainly of carbon dioxide with clouds of sulfuric acid and only small amounts of water. It has the heaviest atmosphere compared to any other planet in our solar system. If you want to experience what standing on Venus's surface would feel like, dive deep into the ocean and stop when you're 3,300 feet down. What you'll feel is a surface pressure 90 times that of Earth. So, any spacecraft that doesn't burn up after entering Venus's atmosphere is crushed due to its pressure. Here's an interesting fact about Venus you probably didn't know. The Venusian year equals 225 Earth years, and while we experience 24 hours to go from one sunrise to another, a day on Venus is 117 Earth days long. One of the reasons for the planet's slow rotation on its axis could be its thick atmosphere that acts as a barrier, causing a sluggish spin. And because of this low rotation, its metal core cannot generate a magnetic field similar to Earth. The magnetic field of Venus is 0.000015 times that of Earth's. Also, the planet rotates in the opposite direction to most planets. So while the sun rises in the west on Earth, it sets in the west on Venus. We have to say the planet is starting to sound more and more like Earth's evil twin. The first successful mission to Venus was the Mariner 2, which made a flyby on December 14, 1962. It was the first time astronomers recorded the planet's temperature. The next discovery came with the Soviet Union's Venera spacecraft that entered Venus's atmosphere in 1967. The spacecraft showed an atmospheric composition of around 90% to 95% carbon dioxide and found no evidence of a global magnetic field or radiation belt. Following the success of these missions, the Soviet Union geared up for its first Venus landing with Venera 5 and 6, identical spacecraft designed to enter the planet's atmosphere. Venera 5 survived 45 minutes after entering the atmosphere, whereas Venera 6 failed to gather much data following its plunge due to a malfunction of the photometer. The first spacecraft to land on the Venusian surface was Venera 7, although its descent was a little too exciting. After entering the atmosphere, the lander's parachute ripped and the probe hit Venus at a very high speed. The spacecraft sent a weak signal for about 23 minutes, but the transmission only reached Earth briefly. Believe it or not, Venera 7 managed to gather measurements from the atmosphere and the Venusian surface despite its crash landing. There were many other successful missions to Venus that offered scientists valuable insight into the planet's makeup. The most recent probe to fly by Venus was the Bepi Colombo, a joint mission by the ESA and JAXA. Although Bepi Colombo's main mission is to study Mercury, the spacecraft flew by Venus in 2020 and 2021. Why do astronomers keep returning to Venus despite its harsh and unwelcoming atmosphere? Why is it important to study Venus and its evolution? You see, Venus was once like Earth. Recent climate modeling shows Venus had surface temperatures similar to Earth for billions of years. It probably had oceans, rain, snow, continents, plate tectonics, and even more speculatively, surface life. Then, suddenly, around 1 billion years ago, the climate on Venus drastically changed due to a runaway greenhouse effect. Scientists speculate that the planet experienced an intense period of volcanism, which pumped carbon dioxide into the atmosphere, heightening the greenhouse effect to the extent that all the oceans evaporated, signaling the end of the water cycle. So how did a planet that was once brimming with water and perhaps life, much like Earth, suddenly deteriorate catastrophically? Can the events that led to the runaway greenhouse effect in Venus's atmosphere repeat themselves on Earth? Can Earth turn into Venus? These are important questions, and the answers are waiting for us on Venus. Therefore, astronomers look forward to landing on the Venusian surface, collecting samples, and transmitting data to understand Venus's evolution and possibly our own. After all, the only way to predict our future is to map and analyze Venus's past. Fortunately, we are finally close to unveiling when and how our stories diverged with NASA's planned mission to Venus Da Vinci, which is scheduled to launch in 2029. Da Vinci stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. And according to NASA, this mission will provide answers for: did Venus harbor oceans? Was it habitable? What exactly is happening on its surface? By 2031, the Da Vinci spacecraft will drop a 3-foot-wide titanium sphere through Venus's thick clouds, which will ingest gases and run experiments on its way down to the surface. The probe will capture images of Venus like we have never seen before, and if everything runs smoothly, just a single hour of observation by the Da Vinci will be enough to transform our understanding of Venus. How will the spacecraft endure the crushing pressure and lead-melting temperatures of Venus? The Da Vinci probe is spherical and covered in a thick titanium shell, one of the strongest metals on Earth. Then, there's more insulation inside this shell, made of unique materials, including astroquartz, a type of fiber made from fused quartz. The sphere's interior is designed to keep components thermally insulated from the exterior and filled with carbon dioxide gas to protect the high-voltage electronics from sparking and stop Earth gases from leaking during launch. The descent sphere will travel through the atmosphere and collect samples all the way down to create a picture of the atmosphere from the top to the bottom. The probe is designed to sample the atmosphere, but not the surface. Since astronomers aren't expecting the sphere to land safely on the Venusian surface, it is equipped with all the instruments it would need for a thorough observation throughout its descent. However, there are chances that the thick atmosphere and parachute will slow down the sphere's speed enough to survive the landing and continue sending back valuable information. We are talking about another 20 minutes of collecting data before the heat soaks through the sphere and fries the electronics. NASA's Da Vinci is tentatively scheduled to launch in June 2029 and enter the Venusian atmosphere in June 2031. Are you excited about NASA's mission to Venus? Let us know your opinion in the comments below. Thanks for watching this video. Remember to hit the like button, subscribe to our channel with the notification bell for more thrilling space videos. Until next time.